Welcome, Algebra 1. This is section 2.1, solving one-step equations. The essential question is, how do you know when you should add, subtract, multiply, or divide to solve? Let's begin. So, the main goal of chapter 2 is to learn how to isolate the variable. Say that out loud. Isolate the variable. Say it again. You have to know this and you have to repeat this. This is the key part to this. So, what do I mean by isolate? Well, you have an equation that looks like this on the left, and then 3x minus 5 equals 10, and then we do some math to it, and it turns into x equals 5. The x is now isolated. The x right here, he's got some friends. He's got this 3, and he's got this minus 5. Now he's got nothing. He's alone, forever alone, isolated. You have to isolate. Whenever you do this, ask yourself, what am I doing? Does this help me isolate the variable? Isolate the variable. To isolate the variable, we must perform the same operation on both sides of an equation. So it's not just, if we want to add 5 to one side, we have to add 5 to the other. If we want to divide one side by 2, we have to divide the other side by 2. Both sides of the equation. So there's an equal sign, there's a bunch of stuff on the left, a bunch of stuff on the right. If you want to add 5 to the left, you must add 5 to the right. If you want to divide by 2 on the left, you must divide by 2 on the right. The equal sign is a dividing line. So you have to do it on both sides. Now, let's look at this. There's 4 different ways to solve one-step equations. So the first way is subtracting from both sides. You do this when a number is added to the variable. Added, so you're looking for a plus. So you're looking on the side that actually has the variable. Let's do this first case, x plus 2 equals 5. There is a plus 2 on this side, so it's adding 2, so we want to subtract 2 from both sides. So 2 is added, so we subtract 2. On both sides of this equal sign, right? The left side and the right. These 2's cancel out because they go to 0. So you're left with x equals 5 minus 2 is 3. And x equals 3 is my answer. This x is isolated. It is isolated. There's nothing else next to this x. Now let's look at the second equation. The x is on the right. That's okay. But it's x plus 8. We want to subtract that 8. So when we have 8 is added, we want to subtract to it. So we subtract 8 on both sides of this equal sign. And these 8's go away, they cancel out. We get 7 minus 8 will be negative 1. So x equals negative 1. That x is isolated. Now another way is adding to both sides. You add to both sides when a number is subtracted from the variable. So looking at this first equation, what's happening? Well, we're subtracting 2. 2 is subtracted, so we want to add to both sides. So I'm going to add 2 to both sides. Plus 2 and plus 2. The plus 2 and minus 2 cancels out, so I'm left with x equals 5 plus 2 is 7. That x is isolated right here. So we can say x equals 7. Now this bottom one, again, 8 is being subtracted, so we have to add 8. Plus 8 on both sides, the left and the right. And the 7 plus 8 is 15. These 8's cancel out, so I get 15 equals x, or x equals 15. The x is isolated. Now, another case, when you have to divide to both sides. You do this when a number is multiplying with the variable. So you're looking at the variable. You have to point at the variable, and the variable is right here. We have a 2 times the x. When it's 2x, that means 2 times x. 2 times x. That's what's going on right there. So when 2 is being multiplied, you have to divide. You do the opposite there. So what's that going to look like? I'm going to divide both sides by 2. So do this dividing on 2 and dividing by 2 on the right. So on the left, the 2 and the numerator and denominator, they cancel out. So all you're left with is an x. On the right, 10 divided by 2 is 5. So my answer is x equals 5. On the bottom, well, we got a 4 times x. Not the 1, the 4 times x. So 4 is being multiplied, so we divide. And when you divide on each side, you divide by 4. Now these 4's cancel out, so I get left with an x. On the right, I have 1 divided by 4. It doesn't simplify anything, it's just 1/4. You leave it as that. It's okay, you can divide and get a number less than 1. We're okay with fractions in Algebra 1. Now let's try next when we multiply to both sides. This happens when a number is dividing the variable. So we look at this case of this equation. X is being divided by 2. 2 is dividing, so you want to multiply it. To get rid of that divide by 2, I multiply both sides by 2. And what I do is I do like a little times on the outside, times 2 on both sides of the equation. Now this 2 is actually on the numerator, it's like 2 over 1. So those actually cancel out here, these two 2's. And all you're left with is x equals 8 times 2 is 16. So when you multiply, it's going to cancel out with what you're dividing by. Alright, let's try the bottom one here. X being divided by 7. 7's dividing, so you multiply by 7 on both sides. What happens? These 7's cancel. I'm left with x. 7 times negative 3 is negative 21. So x equals negative 21. Let's try some examples. So pause the video. And let's try this. We want to solve it and check the answer. So I got an x plus 7. That means I want to subtract 7 on both sides. So these 7's cancel. I get x equals 3 minus 7 is negative 4. That's my answer. Let's check it. And you check it by plugging negative 4 in for x. So I'm taking that equation. Let's write that original again. X plus 7 equals 3. And then I'm going to plug in negative 4 for x. So I get negative 4 plus 7 equals 3. So what's negative 4 plus 7? Well, that's 3. And 3 does equal 3, so that checks out. Let's try the next one. Pause the video. Alright, let's solve this. So m minus 4, when it's subtracting here, I want to add 4 to both sides. Do that opposite. So these 4's cancel. I'm left with m equals 9 plus 4 is 13. So m equals 13. Let's check that answer as well. So it'll be 9 equals, instead of m, I'm going to plug in 13. And then it's going to be minus 4. Well, 13 minus 4 is going to be 9. And we have a 9 on the left, so 9 equals 9. That checks out. Let's try another one. Pause the video. Alright, it's 5y, which means 5 times y. And when I have times, I'm going to divide by 5. Divide by the number next to the y, not the one on the other side of the equation. So these 5's cancel out here. I'm left with y equals 24 fifths. So 24 divided by 5. You can't reduce that. I don't care for it to be a mixed number or decimal. Just leave it as an improper fraction. So y equals 24 fifths. Let's check that work. So we're going to get 5 times 24 fifths. So I'm going to write that as 24 fifths equals, let's just do 2 parentheses, equals 24. Well, when you're doing 5, that's like 5 over 1 times 24 over 5. Those 5's are cancel out. So I'm left with 24 equals 24, and that checks out. Last one. Pause the video. 2, 1. Okay, let's try this. So it's negative x divided by 7 equals 10. Well, I want to get rid of this 7. And since it's a negative, I want to also get rid of that. So instead of just multiplying by 7, I'm going to multiply by negative 7 on both sides. Because you want to get rid of the negative as well. Because you have to isolate the x. Negative x is not isolated. So what happens is a negative times a negative turns into a positive. So those negatives cancel out. And then the 7 divided by 7, that cancels out. So I'm left with x equals 10 times negative 7 is negative 70. So that's my answer. Let's check it out. So if I plug that in, I'm going to get negative x. Instead of x, it's going to be negative 70 over 7 equals 10. We have a negative 70. So what happens with those? Two negatives cancel each other out, so it's positive. And 70 divided by 7 is going to reduce to 10. And 10 equals 10, so that checks out. We're done.